In this video, we're going to talk about how to convert a hexadecimal number into an octal number. So how can we go from a number in a base 16 system to a number in the base 8 system? Well, let's start with this example. AC. How can we convert that to an octal number? Well, first, we need to change the letters A and C into numbers. So you need to know that A in the hexadecimal system corresponds to 10 in the decimal system, B corresponds to 11, C corresponds to 12, D corresponds to 13, E is 14, and F represents 15. So we can replace A with 10, and we can replace C with 12. Now, our next step is to convert these two numbers into binary numbers. So let's use the numbers 8, 4, 2, and 1 for each of them. Keep in mind this is 2 to the 0, 2 to the 1, 2 squared, and 2 cubed. So 10 is the sum of 8 and 2. So we're going to replace 8 and 2 with a 1, and the numbers that we didn't use, we're going to replace with 0. 12 is basically 8 plus 4. So let's replace those two numbers with a 1, and 2 and 1, let's replace it with a 0. So 10 is equivalent to the binary number 1010, and 12 can be represented as 1100 in the binary system. Now the next thing we need to do is regroup the binary numbers. Right now, they're represented as groups of 4, but we need to change it to groups of 3. So the first group of 3 is 1000. I said that wrong. It's 100. And the second group of 3 is 101. And then the last one, we only have two numbers, so we're going to add a 0 to it. So let me get rid of this. So I'm going to add a 0 here. So it's 0, 1, 0. And then in blue, I have 101. And in red, 100. So let's convert these three groups of numbers into a decimal value. So here we have a 4 and a 2 and a 1. So we need to multiply 0 by 4, which is 0, 1 by 2, which is 2, and then 0 by 1. So we only have a 1 next to the 2, so the decimal equivalent here is going to be 2. In this example, we have a 1 next to the 4 and the 1, so 4 plus 1 is 5, thus the decimal equivalent is 5. And for the last example, we only have a 1 next to the 4. So 100 as a binary number equates to 4 as a decimal number. And so reading it from left to right, we have our answer. So AC in the hexadecimal system is 254. That's a terrible looking 5. It's 254 in the octal system. And so that's how you can convert a hexadecimal number into an octal number. Now let's try this example. 1EF. Let's convert that from the hexadecimal system to an octal number. Now we need to change the letter E into its decimal equivalent. So E corresponds to 14, F corresponds to 15. So now let's change these numbers into their binary equivalents. So let's use 8421. So here all we need is a 1, and so everything else we're going to replace it with a 0. To get 14, we need to add up 8 plus 4, which is 12, plus 2. And so this is going to be 1110. So every number that we use, replace it with a 1. To get 15, we need to add up all 4 of these numbers. So it's going to be 1111. Now our next step is to adjust the binary numbers from groups of 4 into groups of 3. So here's the first group of 3, and then here is the second group of 3, and then here is the third group of 3. And for the last group, notice that we don't have any 1, it's just 0. So we don't need to use that. So the first group is 1, 1, 1, the second is 1, 0, 1, and then the last one is 1, 1, 1. Now when dealing with binary numbers in groups of 3, use 4, 2, 1. When dealing with binary numbers in groups of 4, use 8, 4, 2, 1. So for this example, we have a 1 next to all of these. So we need to add up 4 plus 2 plus 1, which is 7. For the next one, we have a 1 next to the 4 and the 1. So it's just going to be 4 plus 1, which is 5. And for the last one, it's the same as the first. 4 plus 2 plus 1 is 7. So thus we could say that 1 EF in the hexadecimal system corresponds to 757 in the octal system. And so that's it for that example. Now let's try another one. 1F2C. Feel free to pause the video. So we have a 1, and then F corresponds to 15, and then we have a 2, and C, well, A is 10, B is 11, C is 12. So let's use the numbers 8, 4, 2, 1. So here we have a 1. So as a binary number, that's going to be 0, 0, 0, 1. 15 is the sum of all 4 of these. So that's going to be 1, 1, 1, 1. And then 2, we only need to use this number. So it's going to be 0, 0, 1, 0. And for the last one, to get 12, is simply 8 plus 4. So that's going to be 1, 1, 0, 0. Now let's break it up into groups of 3. So this is the first group of 3. And here is the second group of 3. And then we have the third group. And then this one makes the fourth group. And then this is going to be the fifth group. So the first group on the left is 0, 0, 1. And then we have 1, 1, 1. And then 1, 0, 0. And then 1, 0, 1. And then 1, 0, 0. So let's convert these binary numbers in groups of 3 to their decimal equivalents. So we only have a 1 here in this column. So this is equal to 1. For this one, all of them is associated with 1. So it's 4 plus 2 plus 1. Therefore, that corresponds to a 7. Here we only have a 4. So that's just 4. And then for the one in the middle, it's going to be 4 plus 1, which is 5. And then for the last one, we only have a 4. So that corresponds to 4. And so we could see our answer as we read it from left to right. So thus we could say that 1F, 2C in the hexadecimal system is 17,454 in the octal system. So this is the answer. Now, let's check the work. So we're going to convert each of these numbers into a decimal number and see if they give us the same result. So let's start with the hexadecimal number 1F, 2C. So we're going to multiply C by 16 to the 0 power, and then 2 by 16 to the first power, F by 16 squared, and 1 by 16 cubed. So it's going to be 1 times 16 to the third power, plus F is 15, so that's 15 times 16 squared, and then 2 times 16 to the first power, and C is 12, so 12 times 16 to the 0 power. So 16 cubed, 16 times 16 times 16, that's 4,096. 16 squared is 256 times 15, that's 3,840. 2 times 16 is 32, 16 to the 0 power is 1 times 12, gives us that. And so it's 4,096 plus 3,840 plus 32 plus 12. And so the sum total is 7,980. So now let's convert the octal number into its decimal equivalent. So we have 17454. So the first number, 4, we're going to multiply by 8 to the 0, and then the next number by 8 to the first, and then we're going to follow this pattern. So it's going to be 1 times 8 to the 4th, plus 7 times 8 cubed, plus 4 times 8 squared, plus 5 times 8 to the first power, plus 4 times 8 to the 0 power. So 8 to the 4th power, if you multiply 8 4 times, it's going to give you 4,096. And then 8 to the 3rd power is 512 times 7. That's going to be 3,584. 8 squared is 64 times 4. That's 256. 5 times 8 is 40. 8 to the 0 is 1 times 4 gives us that. So let's add 4096 plus 3584 plus 256 plus 40 plus 4. And so you get the same sum of 7,980. And so because these two are the same, we know that 1F2C in the hexadecimal system corresponds to 17454 in the octal system.